Yeah. Hello everyone, welcome to YourPedia. We are going to start the solutions of a previous HPCL electrical paper 2022 shift 1 paper. We are going to solve all the 85 technical questions. We are going to solve all the 85 questions from 1 to 85. All the questions we are going to solve today. All the subjects like I can say start from EMFT. There are few questions on EMFT. There are few questions from network analysis, few questions from power system, few questions from I can say like electrical machines and measurements. Okay, these are the important subjects. These are the very important subjects. Okay, so one by one, all the questions with explanation, with very good explanation, we are going to see one point here. We have to note that HPCL electrical paper questions are damn easy, very easy. See, I would like to tell you one point here, that the questions are just they picked from the concepts, so there is no depth in the question. Only see the point when you are, see, remember one thing, that when you're preparing for HPCL examination, you have to cover all the syllabus. You need not to go in depth. Suppose if you come for power system, there is a LLG fault, line to ground fault. If it is gate examination, more in-depth questions are possible. But he gives some diagram. He asks what kind of fault is this? It is symmetrical or asymmetrical fault. So that type of very simple questions were asked previously in all the papers of HPCL. Okay, so those who are feeling that the gate is tough, for them this is the very good opportunity to grab. Okay, HPCL paper is easy if you work hard, and if you complete the syllabus in time, complete preparation, then getting this HPCL job is going to be very easy, right? See, let's come for the first question. The very first question is from EMFT, electromagnetic field theory. See, electrical people also will read EMFT in their BTech. Okay, now the first question is, which of the following options gives the correct correlation between the variables of rectangular and cylindrical coordinate system if x, y, z are variables in rectangular coordinate system, comma, rho, it is rho, or p. See, in the paper it is typed as p, but we taken generally it as rho. Generally we'll take it as rho. Okay, rho, but it is p also, no problem. P comma phi comma z are the variables in cylindrical coordinate system. See, this is one of the very simplest question, direct question. Okay, direct question from the concept. The relationship here is rho is equal to under root of x square plus y square, and phi or theta is equal to tan inverse of y by x, and z is equal to z. This is the relationship between rectangular coordinates and cylindrical coordinates. Now, which option is going to satisfy? See, rho is equal to root of x square plus y square. You see option A, p cos phi, p sin phi. Yes, z is equal to z. This got satisfied. If it is cos phi, it is sin phi. Then this is going to be equal to rho. And if it is tan inverse of y by x, y is p sin phi and x is p cos phi. Yes, it is equal to tan inverse of p cos phi or rho cos sin phi. Please, y is sin phi, y is p sin phi or rho sin phi. Sin phi by, yes, p cos phi. This p gone. Tan phi, sin phi by cos phi is tan phi. Tan inverse of tan will be phi only. This is satisfied. So option A suits well. Or option one. So in the HPCL examination, given 1, 2, 3, 4. Option 1 suits very well. This won't suit. Why? Because if you go for the relationship rho is equal to root of x square plus y square, this is not going to satisfy. This will satisfy the first relationship, but whereas the second relationship is not going to be satisfied. You're going to get phi is equal to pi by 2 minus theta, something like that. Okay, that is not satisfying. Therefore, option 1 suits very well. That much simple the given question is. Let's go to the second question. See, the second question is also very easy question, direct question. What is saying? With the help of a 4.5 digit. What does it mean by half digit? That half digit is able to indicate 0 or 1. Okay, but a full digit is able to indicate from 0 to 9. Means he's saying that he is having a digital voltmeter. Yes, this is first, second, third, fourth, fifth. So this particular one is half digit. This is half digit. Okay, means it's the possible values of this half digit are 0 or 1, but this possible value is 0 to 9. This possible value also 0 to 9, 0 to 9, 0 to 9. The question is, with the help of a 4.5 digit voltmeter, the largest possible reading is asking about the largest. What is the largest number here? Yes, 9, 9, 9, 9. In 0 or 1, what is the largest number? 1. Yes. Now, if you take up this 1, 4 nines is the answer. Choice 3. Choice 3 is, see, I told you, as I told you in the very beginning already, that all the questions are very, very, very simple. See, comment your answer in the options if you're solving. Okay. As if some of you solving along with me, comment your answers. Comment your answers. I'll be going through your comments, or something extra you required in explanation also, just let me know, I'll explain. Okay. I want I want you to you to reply. I want you to reply here for sure, right? Yeah. So this is the second question. The third question here is, let's go to the third question. He is asking about the polarization. Yes. What is this? Polarization is defined as, yes, it is the dipole moment per unit volume. This is direct bit. Okay. So nothing to I can say like discuss here. Polarization is yes, it is a dipole moment per unit volume. It is per unit volume. Next one. Yeah, fourth one. This is the question to solve. This is the question to solve. You see, there are good number of questions from EMFT. People will feel that. See, most of the electrical people will feel that EMFT is not that important. But I can say like EMFT is also one of the important subject. Yes, EMFT is also one of the important subject for electrical people. Why? Because there are good number of questions in HPCL examination. See, in the middle, when we come across some questions, then I'll be telling you from which subject good number of questions has been appeared, from which topic, in fact, not if you go for network analysis, that mutual induction, self-induction topic is very important. See, whereas the topic is not that important in I can say gate-like examinations, but in this HPCL examination, more than one question has been asked from mutual inductance and self-inductance. Okay. Yes or not? Yeah. Let's read this question. An infinite, yeah, infinite uniform line charge of 5 nanocoulomb per meter. Yeah, he's saying that line charge is taken this way. Line charge, yes, an infinite line charge rho L is taken. He given as 5 nanocoulomb, 5 nanocoulomb per meter. Coulomb per meter, line charge it is, that's why it is per meter, along the positive and negative xy axis in free space. Find the electric field intensity E at PA 004. So he given charge in x and y plane. He's asking electric field intensity in z plane. Okay. Now here we have two electric field intensities. One is from x, another one is from y. Therefore, E total electric field intensity E total is equal to E1 plus E2, where E1 is equal to rho L by 2 pi epsilon naught rho into, yes, AZ. This is E1. I'll tell you what is rho L. Yeah, rho L is line charge density. Yes, he already given line charge density. It is given as 5 nanocoulomb per meter. Yes, and this rho is this distance, 4. The distance from the point to the z-axis. Okay, from the point to the z-axis, it is 4, and E2 will also be same. E2 is also same, line charge density by 2 pi epsilon naught into rho. Then what is the total? What is the total one? Yeah, let me take the total one. Yes, E T is equal to, so E total is equal to, I can say like 2 into rho L by 2 pi epsilon naught into rho. Now Et is equal to 2 into, this is 5 nanocoulombs, 5 into 10 to the power of minus 9 by this rho is 4. This 1 by 2 pi epsilon naught is simply 18 into 10 to the power of 9. See, we all know that epsilon naught value is 8.85 into 10 to the power of minus 4. 8.85 into 10 to the power of minus 12, not 4. See, epsilon naught is equal to 8.85 into 10 to the power of minus 12 farad per meter. Then 2 pi epsilon naught, in fact 1 by 2 pi epsilon naught, you remember, that will save your time in the examination. That is simply 18 into 10 to the power of 9. 18 into 10 to the power of 9. Now if I simplify this one, this 2 times gone, this how much it is? 9. This 10 to the power of 9, 10 to the power of 9 gone. Then you're left with the 9 into 5 will be 45. Yes, 45. Come back. What is the option? 45 AZ volt per meter. Yeah, it is electric field intensity, always it is per meter. Electric field intensity always per meter. See, comment if you are see, I told you, you also can solve. You also can solve. You solve it and let me know the answer. You solve it and let me know the answer. Right. The next question is, in a single phase semi converter. Yeah, he's saying that single phase semi converter. How single phase semi converter looks? Semi converter means it is going to have one diode and one thyristor. One diode and one thyristor. Semi converter it is. Single phase semi converter for continuous conduction. There is a freewheeling diode also. He said that there is a freewheeling diode. Yes, and there is a load here. For time being, I'm taking RL load, though he did not mention. I'm taking it as RL load. Yes, yes or not? Yes. Now this is the source bridge converter I taken. Yes. Now, what is saying for continuous conduction, freewheeling diode conducts for dash if firing angle is alpha. Now, see, when you are giving firing angle at alpha, alpha to pi, this is the path. Alpha to pi, this will be the path. So I'm talking about positive half cycle. During positive half cycle, this is the path from alpha to pi. But after pi, there is freewheeling diode. Yes, after pi, there is freewheeling diode. So pi to alpha, I can say, yeah, pi to alpha, this freewheeling diode will conduct. Therefore, freewheeling diode will conduct for alpha. It is not A, it is alpha. Option 3. Alpha it is. Okay, the freewheeling diode will conduct for alpha degrees. All are direct questions, simple questions. All are direct questions. See, come on, ma, answer. You just do it. Okay, if you have any query, please drop in the chat box. I'll read it and I'll explain your query for sure. Yeah, the sixth question, it is also direct question. If the percentage reactance of an element is 20% and the full load current is 40 amperes, then the short circuit current will be dash amperes when only that element is in the circuit. Yeah, that is very simple formula. This is also direct formula. That is equal to full load current by full load current by reactance, short circuit reactance. Short circuit, yes, reactance, and that is equal to, what is the full load current given? 40 amperes. This is given 20%. In percentage, it is 20, means normal value is 0.2 only. Na? Yes, it is 0.2. The answer will be 200 amperes. Yeah, he asked about the full load short circuit current. Yes. Yeah, how much it is? 200 amperes. Option 2. 6 is option 2. Direct question. This is also. Let's go to the next question. Which of the following types of instrument is used for the standardization of polar type AC potentiometer? It is thermal instrument. See, there is no discussion or explanation here. Direct question, that is direct question. That's why I'm saying you have to go through all the topics of a given HPCL syllabus. You need not to go in depth. Sir, what is thermal instrument? How thermal instrument measures? What is the construction of thermal instrument? Construction not required, but what is thermal instrument? How it does? All these things are required. Okay, this is directly option 4. It is. Let's go to the next question. In the field flux control method of DC motor speed control, he's saying that field flux control. He's varying the field to control the speed of DC motor. Dash see control dash power and a dash torque is obtained for the speeds above base speed. He's saying that speed is above base speed. Now we all know that speed is inversely proportional to flux. Or sir, how you got this relationship? I'll write here. E is equal to, yeah, back EMF is equal to phi ZNP by 60A. This is one of the relationship. This is one of the relationship, right? Now we all know that power is equal to torque into speed. Torque into speed, right? Power is equal to torque into speed. If I vary flux, if flux increases, speed will decrease. So I'm going for variation of the flux. I'm going for the variation of the flux. Just yeah, if I'm varying flux, suppose if I'm increasing flux, speed will decrease. But as the machine is a constant power machine, yeah, constant power machine it is. He did not told anything about the load. He did not told anything about the load, and we are the speed above the base speed. Therefore, power should be constant. If power is constant, if speed is decreasing, torque will increase. What he asked? And the field flux control method of DC motor speed control, constant power and variable torque is obtained for speeds above base speed. Suppose if I'm decreasing the flux, speed will increase, then torque will decrease, but power is equal to constant. Okay, constant power and variable torque. Yes, constant power and variable torque. Yes, power is constant, constant power and variable torque is obtained for the speeds above base speeds, right? Let's go to the next question. This is a direct question formula, only one formula, one step, not more than one step I'm going to take for this one. A synchronous generator is rated at 40 MVA. Yeah, its MVA, S is equal to 40 MVA. Yeah, and 10 kV and 50 hertz. Okay, voltage rating is equal to 10 kV. It is. The base impedance of the generator will be Z base is equal to, yes, V base square by S base. What is V base, ma? V base is 10 into 10 cube whole square by, this is 40 into 10 to the power of 6. This is 100 divided by 40, that is equal to 2.5 ohms directly, choice 4. 2.5 ohms directly, choice 4 it is. Okay, see, please reply me in the chat. Okay, if you have any question, please reply me in the chat. Okay, yeah, let's go to the next question. This question is from DC machine. You see how many questions we are getting from DC machine. Okay, machines, in fact, not DC machine. Important subjects are electrical machines, power systems, power electronics, electrical measurements, and electrical measurements. Okay, in electrical measurements, electronic measurements also are important. Okay, just my point is electrical means both electrical and electronic measurement, right? Because the second question itself is from DVM, digital voltmeter. That is from electronic measurement, electrical and electronic measurement, power systems, power electronics, electrical machines, network analysis. Very good number of questions you are going to get from network analysis also. Okay, let's read this question. Yeah, in DC machine, the method of achieving good commutation with help of interpoles is called as, it's called as EMF commutation or voltage commutation. With help of interpoles, if we are achieving good commutation, it is called as a voltage commutation or EMF commutation. Yeah, that is also direct question. Yeah, which of the following materials offers the largest value of dielectric constant? Yeah, sorry, in which subject will encounter this type of questions? See, in electrical measurements, sometimes you read about this dielectric constant, or in power systems. Yeah, in power systems, when we are talking about, I can say like transmission lines, capacitance of transmission lines, will encounter about dielectric constant and all. Okay, or in material science, but you need not to go for entire material science to answer this type of questions. The material science which is related to electrical engineering. Okay, see, the dielectric constant of various materials, and the dielectric constant of various materials, you can remember. Yeah, see, answer is silicon. It is going to have 11.6. Yeah, it is going to have 2.1. It is going to have around 3.6. It is equal to 1. So here nothing to understand, just to remember. Okay, yeah, see, the relative permeability and this relative dielectric constant or permittivity, dielectric constant. So these things are very important for certain materials. Okay, so those you can find in anywhere in a textbook, or you can Google it also. You can get those values. So I request you to remember those values. Not all values. There are a number of I can say materials. For all those it is not required, but the materials which we use generally in electrical engineering, you have to remember. Let's go to the next question. How many parallel circuits are formed in a 4-point starter? The answer is 3. Yeah, if you look at the circuit of a 4-point starter, 3 parallel paths or 3 parallel path combinations are possible. That is also a direct question. Yes, let's go to the next question. If the flux produced by one coil does not link with other coil, if the flux produced by one coil is not linking with the other coil, is there any mutual induction between those two coils? No, there is no mutual induction. Yeah, then the value of the coefficient of coupling, will be 0. See, what is the formula? The formula is mutual inductance is equal to K into under root of L1 L2. You see, I told you this topic. What is that topic? Mutual inductance, self-inductance topic is very important for this particular examination. I told you, right? So not only this question, we have 2 or 3 more questions from the same mutual and self-inductance topic. Okay. Now he's saying that the flux of one coil is not linking with the flux of another coil. Flux of one coil is not linking with the flux of another coil. It means to say that there is no mutual induction between those two. Therefore, M is equal to 0. K into under root of L1 L2. L1 is not equal to 0. L2 is also not equal to 0. Therefore, what should be is equal to 0? K equal to 0, where K is called as a coefficient of coupling. K is called as what? Coefficient of coupling, right? K is called as coefficient of coupling. So it is equal to 0. Let's go to the next question. Identify whether the given statements are true or false. Electric susceptibility is unitless. Yes, it is unitless. See, what is electric susceptibility? If you apply electric field, how much portion of the material is getting polarized is given by this electric susceptibility, that is unitless. Okay, in ferromagnetic materials, the relationship between polarization and electric field intensity is non-linear. That is also true. See, if you draw this polarization versus electric field intensity, you are going to get yes, it is similar to the BH curve. It is similar to the BH curve what we get for a magnetic material. This is for electric material. Sorry, this is for electric material. Yes, polarization versus electric field intensity. Both are true. Both are true. So electric susceptibility is unitless. Yes, in ferromagnetic materials, the relationship between polarization and electric field intensity is non-linear. Both are true. 1 and 2 both are true. Okay, yeah. Next question. This is one of the direct and simple question. One of the simple and direct question. See, please reply in the chat box. Okay, that will give me more energy to teach all these things to you. See, that what he's saying, in a simple coplanar network, there are 7 branches. Number of branches is equal to 7, and 4 junctions. Junctions means nothing but nodes. 4. 7 branches, 4 nodes. How many mesh currents are required for the solution of the network? See, number of loops, independent loops, is equal to b minus n plus 1, where b is 7, n is 4, plus 1, it is equal to 4. Choice 3 it is. Choice 3 it is, right? Let's go to the next question. With a reference to the skewing of the cage rotor, squirrel cage rotor, in fact, he did not mention the squirrel, it is a squirrel cage rotor. Cage rotor means of an induction motor, identify whether the given statements are true or false. Due to skewing, the noise is reduced during operation. What is the main advantage of skewing? Skewing is skewing of the squirrel cage rotor induction motor is to reduce the noise and to reduce the tendency of magnetic locking. Okay, yeah, both the options are true. The locking tendency of the rotor is reduced. Both the options are true. Therefore, both the statements are true. The choice 4 is perfect for that. Let's go to the next question. A single phase full converter bridge has 4 SERs. Yeah, bridge converter. Previously we drawn semi converter. Yeah, now this is a single phase single phase full converter. Full converter, that to bridge it is. Yeah, it is a bridge converter only. Now I'm taking load here. Some some RL load I taken. Okay, so need not to be that. For the given question, it is nothing to do with the load. What type of load you may take, that doesn't matter. What type of load you are taking, that doesn't matter. This is thyristor 1, thyristor 2, this is T3, this is T4. So all four are SERs. Choice 3 it is. Direct question. This is also. Now this is from network analysis. You see how simply given the question. He's asking about R equivalent, resistance equivalent. You see, you know these two are in series. That is in parallel with this. This total is in series with these two, right? Yeah. Within one step I'll do. R equivalent is equal to 52 plus 28 in parallel with 20, that is in series with 15 and 25. So R equivalent is equal to, this is 80 in parallel with 20 will be 16. 80 into 20 by 80 plus 20. 80 into 20 is 1600 by 100, it will be 16. 16 plus 25 plus 15 is 40. The answer is 56 ohms. Choice 3 it is. Choice 3. Direct question. See, even at diploma level, see, this question does not fit for even for diploma level. Okay, that much simple it is. Let's go to the next question. In a single phase transformer, the ratio of transformation is 2. Means he is saying that K is equal to N2 by N1. Yes, transformation ratio means N2 by N1. Turns ratio means N1 by N2. Please do remember. Okay, some people will have confusion in this, right? 2. And the secondary resistance is R2. He is saying that 0.24. Find the resistance of the. So he's saying that secondary resistance is 0.24. Find the resistance of the secondary in terms of primary. So our relationship is R2 by R1 is equal to N square. So from this, R1 is equal to R2 by N square. What is R2 ma? 0.24 by N square is how much is K? He given K is equal to I'll take it as a K, not N square. It is K square. I take this one as K square. It is not N square. Yeah, I'll write here. This is K square. Yes, this is k square. It is equal to 4. How much it will be, ma? How much it will be? Yeah, it is 0.6. Yeah, it is 0.6. 0.24 by 4 will be 0.6. Yes, 0.6. Let's go to the next question. Mesh cannot be defined for dash network, for a non-planar network. For the mesh to be defined, definitely the network must be a planar network. If it is non-planar, the mesh, the standard definition of mesh is not applicable. The standard definition of mesh is not applicable, right? Yeah. Now let's go to the next question. Let's go to the next question. Find the current in the given circuit. This is also direct question. Ohm's law. I is equal to V by R. What is the voltage? 12. By total resistance is all three resistances are in series. So 300 plus 400 plus 100, it will be 800. 800 means 0.015 amperes. It is choice 1. Choice 1 is perfect for the given question. Yes, let's go to the next question. This question, yeah, this is the question where at least I have to write two equations. Okay, till now all the questions are direct questions. Here at least one or two equations I have to write. See the way I'm going to do. See the way I'm going to do in a very simple way. I'm not going to take any hectic procedure. This voltage is 0 volts he mentioned. This is A. So this voltage is V, that voltage is VA. You tell me 3 amperes is coming. Here 1 ampere is coming. Now how much is the current that is flowing here? The current that is flowing here is 4 amperes, right? The current that is flowing here is 4 amperes. Now I'll write KVL there, sorry, KCL there. Then what is the current that is leaving from there is VA by 3 is one current. I'll assume that it is leaving. Okay. Another current that is leaving is 3 amperes. The current that is entering is equal to 4. What KCL says, the sum of the currents entering at a point is equal to the sum of the currents those are leaving. Sum of the currents entering at a point is equal to sum of the currents those are leaving. What is the current that is entering? 4 amperes is entering. How do I know that 4 amperes is entering? 3 amperes is coming, 1 ampere is coming. At this node, if I apply KCL, 3 plus 1, 4 is coming, therefore 4 has to leave. Leaving from here means entering at this node, that is equal to 4 amperes. 4 is entering, VA by 3 is leaving. Directly I can apply Ohm's law here. Why? Because this is 0 volt, this is here, therefore VA. VA by 3 is leaving and 3 is also leaving. So VA by 3 is equal to 1. That implies VA is equal to 3 volt. Done. I got this voltage as 3 volts. Right? If that is 3 volt, how much is the current in this one? 1 ampere. This current is 1 ampere, in fact. This current is 1 ampere. Or directly also I can apply. See, this equation itself is not required. What is another method to solve that one is? Another method to solve that one is I can say like this. Yeah, observe. Sir, 3 is leaving, 4 is coming. Therefore, how much should leave from here? 1 ampere. So 1 ampere into 3 ohms will be 3 volt. In that way also I can get. Now the question is VB. Here somewhat we should not get panic. Some people, sir, here this side the current source is there, this side current source is there. I am unable to write KVL. Then how to get voltage? Yeah, people feel that, sir, I'm unable to know closure path is forming to write KVL. So then how to find it? It's very easy. If you want, you can do with the help of KVL also, but not required. I want VB. Now this voltage VB is equal to this voltage plus this voltage, right? See, you must form a closed path. You must form a closed path. I am forming a closed path this way. Always voltage is measured with respect to reference. That reference is 0 volts. So VB is equal to, what is this voltage? 4 into 2, 4 amperes into 2, 8 volts plus this is 3 volts. How much it is? Directly 11 volts. In fact, no pen paper required for this for this question. For your understanding purpose, I explained by writing all the equations. Without pen paper, you can solve it and you can get 3 volts and 11 volts. Let's go to the next question. Yeah. See, modified MC Murray half-bridge inverter is a current commutated voltage source inverter. It is also a direct question. Okay, you need not to understand anything here. It's a direct question. Okay, if you know about MC Murray half-bridge inverter, yes, it is a current commutated voltage source inverter. It is. Next question. The volume charge. Volume means per cubic meter only, na? Volume charge. Okay, volume per cubic meter. It is. The volume charge density is measured in terms of coulombs per cubic meter. Choice 2, it is coulombs per cubic meter. Let's go to the next question. In DC machine, the hysteresis loss are covered under the category of iron losses. Hysteresis loss comes under iron losses only, na? Yes. Let's go to the next question. Which of the following statements about DC series motor is incorrect? Please read it. He's asking about the incorrect statement, not about the correct statement. First statement is it's a variable flux machine. It is correct only. Flux is getting varied. Yes. Next, it's a speed versus armature current. Characteristics is a straight line. We'll see. He's saying that speed versus armature current is a straight line. This is the relationship we get for the speed versus current of a DC series motor. Right? He's asking about DC series motor only, na? Yeah. If because the field flux is in the armature current only, field current. If current is equal to 0, yes, the field flux will be zero, and the speed will be infinity. Okay, that's why people say that do not run DC series motor under no load, right? So does this relationship will give a straight line? No, it is going to be like this. Speed versus current, armature current will be like this. It's a rectangular hyperbola. It's not a straight line. This is wrong. This is right. Verify the remaining options also. Its speed is inversely proportional to the load current. Yes. Third one is it must never unloaded. Yes, it must never unloaded. Only second one is wrong. That is our answer. Choice 2 is the answer here. Why? Because he asked which of the statement is incorrect. Right? Let's go to the next question. A conductor that connects the distribution substation to the area where power is to be distributed is known as feeder. It is, yeah, feeder is the one which is going to connect from distribution substation to the area to which it has to feed the power. Direct question, it is feeder. Yeah, a DC two-wire feeder, the drop per feeder is 2%, then transmission efficiency of the feeder is dash. Yeah, he's saying that we'll solve it. In a DC two-wire feeder, the drop per feeder is 2%. Okay, find the transmission efficiency of the feeder. Yeah, now VS is VS. VR is equal to 0.98 times of VS, because drop is 2% in the voltage, then sending in voltage is Vs, then receiving in voltage will be 0.98 times of Vs. Now, what is efficiency? Efficiency is equal to output power. Means at the receiving end only we have to calculate. At the sending end it is voltage is Vs, receiving end voltage it is Vr. Now, Vr square by R by, so Vs square by R are gone. So it is Vr by Vs whole square. Now I'm writing here efficiency, percentage efficiency is equal to, yeah, how much is VR? 0.98 Vs by, this is directly Vs only, this is Vs whole square, this Vs gone, it is 0.98 into 0.98. As I told their percentage, therefore it should be into 100, it should be 96%. Yeah, if you calculate it, you're going to get it as 96%. 0.98 into 98 into 0.98 into 0.98 into 100. Let's go to the next question. Read the question. Yeah, which of the following is an example of symmetrical fault? Triple fault. Symmetrical fault means if fault occurs on all three phases at a time with the same fault impedance. Okay, suppose if the same question, suppose if the question is even like this, there is a triple fault occurring with a different fault impedances on three phases, then it comes under a symmetrical fault or asymmetrical fault. Asymmetrical fault. Symmetrical means same fault with same fault impedance must occur on all three phases at a time. Then it is called as symmetrical fault, right? Triple fault it is. Direct question. Yeah, this is also direct question. For a series RLC resonance circuit, two half power frequencies are, he given two half power frequencies. Yeah, solution. He given F1 is equal to 36 kilohertz. In fact, it's not hertz, it is kilohertz, and F2 is equal to 25 kilohertz. Now, what is asking? Find the resonant frequency. We have a beautiful relationship, that is Fr is equal to under root of F1 into F2, where F1, F2 must be half power frequencies. F1 and F2 must be half power frequencies. That is Fr is equal to under root of 36 kilo into 25 kilo. If you solve it, you're going to get it as 30 kilohertz. You're going to get it as 30 kilohertz. So choice 1 is the answer. Let's go to the next question. Identify whether the given statements related to the choppers are true or false. Class A chopper is a step up or step down chopper. No, it is always a step down chopper. Means our power is always flowing from source to load. This particular statement is wrong. Saturable reactor is used in Morgan's chopper. Yes, to limit the output voltage, saturable reactor is used. Two is true. So first one is false, second one is true. Second one is true. So choice one. Yeah, first statement is false, second statement is true. Choice one. Let's go to the next one. In case of slip ring induction motor, external resistors are used or connected in the rotor circuit to increase the starting torque. Yeah, that is the advantage of slip ring induction motor when compared to squirrel cage. In squirrel cage, we do not have that option to connect external resistance to increase the starting torque. Starting torque is going to be varied with help of external resistance R2 in slip ring induction motor. It increases the starting torque and decreases the starting current. Yes, increases to increase the starting torque and to decrease the starting current from the supply. Increase and decrease. Torque will increase, current will decrease, right? In the starting. Yeah, from network analysis, find the voltage at node B in the given circuit. Yeah, find the voltage at a node B. Yeah, node B. This is B. It got missed. Node B. See, this is 0 volt already given. This is 0 volt already given. Okay. Now, what is that voltage VB? So VB is equal to simply minus 12. See, when you are measuring voltage, do remember one thing. Always voltage has to be measured from a given point to the reference. This is the given point and this is the reference. It is minus 12 it is, right? Next question. This is the phasor diagram of a transformer given. Yeah, with reference to the given phasor diagram, current I1 in the phase is current I1 is the phasor sum of. We all know that I1 is phasor sum of I1 dash plus I0. This I0 is no load current drawn by the transformer. This is the no load current drawn by the transformer. You all know very well why a transformer draws no load current. The transformer draws no load current to set up flux and to meet no load losses. This I1 dash is load compensating primary current. Suppose you are keeping load on the secondary, then compensating amount of current will be produced in the primary. Okay, that is I1 dash. So I1 dash and I0, I1 dash and I0. So those I1 dash and I0 carry their usual meaning. Okay, I1 dash means the load compensating primary current. I0 is no load current. Yes, let's go to the next question. The equipotential surface in the potential field of a point charge are dash centered at the point charge. See, you see a good number of questions from EMFT basics. From very basics, we have good number of questions. See, if you take a point charge, this is a point charge. It radiates equally these flux lines, electric flux lines on all the directions, equally in all. See, as it is a 2D plane, I am unable to show you the 3D. So this side, all sides, from all sides, if it is equally distributing the electric field lines, then it forms a sphere. The answer is a sphere. It is not circles, it's not cones, it's not squares, it is spheres, please. Okay. Next question, please. Which of the following statements related to the basic series inverter is incorrect? Let me draw the basic series inverter first. This is the basic series inverter. Yes. Yeah. This is the basic series inverter. This is load, in fact. So this particular one is load, right? This is basic series inverter. Yeah. Now read the statements. Only SCRs he's saying that which of the following statements related to basic series inverter is incorrect. Only SCRs is required for the entire operation. Rating of the commutating components are higher than compared to parallel inverter. The size of the commutating components is higher as compared to parallel inverter. Yes, commutating components are connected in series with the load. Yeah, please read it carefully. Okay. Basic series inverter diagram we taken. Yeah, what is saying? Which of the following statements related to the basic series inverter is incorrect? Only SCRs are required for the entire operation. Yes, only SCRs are only required. See, SCRs and see these elements are also required. Yeah, then fine. It is. He said that only SCRs are required. No, along with SCRs, we need this capacitance and inductance also required. This is the load. This is the load. Therefore, statement 1 itself is not correct. Statement 1 itself is not correct. That is not correct. Okay, choice 1 it is. Let's go to the next question. The peak reverse recovery current of a power diode. Yeah, he's talking about power diode. That is the peak reverse recovery current of a power diode depends on, yeah, it is going to depend upon two things: rate of the current flow, and storage of the charge. Rate of the current flow and storage of the charge. You see, peak inverse voltage, no; temperature, no; storage of the charge, it is also, but that is also included in third one. Therefore, our option is third one: rate of current flow as well as storage of the charge, Okay, let's come to the next question. Yeah, this is a good question. In fact, good question. We will solve it within no time. He's saying that a 1 milliampere ammeter has a resistance of 100 ohms. He's saying that there is an ammeter which is measuring 1 milliampere. Its resistance is 100 ohms. Yeah, this is the meter. Meter resistance is shown here. Calculate the shunt resistance required to convert this one into 1 ampere ammeter. How much this can carry? The maximum amount of current this can carry is 1 milliampere. But he wants this one to be converted as 1 ampere. Then remaining total current must be, I can say, like bypassed through a shunt resistance RSH. Right? He's asking about that RSH value. Now, all of you tell me, what is the current that is flowing through this RSH current? So this is 1 ampere now, because he want to convert that 1 milliampere ammeter into 1 ampere. Then 1 minus 1 milli, it will be 0.999 ampere. Now, both are in parallel. This meter and this shunt resistance both are in parallel, therefore voltage must be same. Now, if that is the case, 0.999 into RSH is equal to 1 milliampere into 100. Therefore, RSH is equal to 100 into 10 to the power of minus 3. How much it is? 100 into 10 to the power of minus 3? 100 into 10 to the power of minus 3 by 0.999. If you calculate it, you are going to get it as 0.1001 ohms. That much resistance you have to keep here, so that our meter will not damage. If you are putting any resistance more than this value, more than 1 milliampere will flow here, then the meter will damage. Right? Choice 2 is correct. Let's go to the next question. See, you see this question, you do not have to read it all. If you read, just no analysis here. Just you read and tick the answer. Which fault is indicated in the given diagram? It is a double line to ground fault or line to line fault. Double line to ground fault. Line to line to ground. Double line to ground fault or line to line fault. Yes. Next question, please. A 350 kilometer line is considered as, it's a long transmission line. Length greater than 180 kilometers, we are going to treat it as long transmission line. Yes, direct question, that is also. Next question. Find the, yes, divergence D at the origin. Means at the origin is asking. At the origin means x is equal to 0, y is equal to 0, comma z is equal to 0. So divergence D is equal to dou by dou x of this e power minus x into sin y plus dou by dou y of this e power minus x into cos y plus dou by dou z of this 2z. 2. This is 2, please. This is 2. Yes. Do it. Now, divergence D is equal to, yes, I'm writing here, divergence D is equal to, yes, minus e power minus x into, yeah, how much this is? Sin y only, because I'm doing derivative with respect to x, plus this e power minus x only, and derivative of cos y with respect to y will be minus sin y, plus dou by dou z, means need not write the dou by dou z, yeah, it is 2. Now, at origin means we have to take, so this is cos y, man. I wrote wrong. This is cos y. This particular one is cos y. Now, x is equal to 0, y is equal to 0, and z is equal to 0. You are going to substitute. If x is equal to 0, cos 0 is 1. Sin y, sin 0 is 0. So 2 minus 1, it will be 1. Yes, 2 minus 1, it will be 1. See, very simple. Or any mistake we committed? I think Let me check the question. Why? Because it is e power minus x into sin y. Yeah, just let me check the question. Question number 41. One second. If there is any mistake in the question, let me check. 41 it is. Yes. Yeah. This is e power minus 2x it is. Therefore, we are going to get, if it is minus 2, here this is minus is there here, minus, I forgot. Okay, minus, this is e power minus 2x. Then this will be minus 2, right? This will be minus 2. Yeah, I'll do in the next page. I'll do in the next page for clarity. Yeah. So divergence d is equal to dou by dou x into e power minus x into e power minus x into, what is this? Sin y. E power minus x into sin y. E power minus 2x in, yeah, it is e power minus x into sin y. I'll correct the question. Plus dou by dou y into e power minus x into cos y plus dou by dou z into 2z, right? Now, if you do it, with respect to x, if you are doing the derivative, yes, with respect to x, if you are doing the derivative, minus e power minus x, this sin y will be sin y only. Sin y is sin y only. Plus dou by dou y into, I'm doing the derivative with respect to y. If I'm doing the derivative with respect to y, e power minus x is e power minus x only. This is minus here, minus. This will be minus. Cos y derivative is minus sin y. Minus sin y. Yeah. Plus this is what this is, dou by dou z of 2. This is 2. Now at origin is asking. At origin means x is equal to 0, y is equal to 0, z is equal to 0. This is 2. If I put x is equal to 0 and y is equal to 0, this is 0, this is also 0. The answer is 2. The answer is 2. Question is correct only. No issues. Right? Yeah. Which option is correct? Which option is correct? Option 1 it is. Option 1 it is. Right? Let's go to the next question. Yeah. Which of the following is the 3-layer 2-terminal device? 3-layer 2-terminal device. You know, we study mostly about SCR. Yes, it is 4-layer 3-terminal device. Let's see. It is triac. Triac is a 4-layer 3-terminal device. 4-layer 3-terminal device. And SCR also 4-layer 3-terminal device. GTO also 4-layer 3-terminal device, but power diode is, yes, 3-layer 2-terminal device. 2-terminal device it is. 2-terminal device. Let's go to the next question. Current IM is asking. Direct question. Okay. Current IM. Now apply current division. Okay. So IM is equal to minus 5 into 10 by 10 plus 10. It is how much it is? 20 minus 50 by 20. Yes, it is minus of 2.5. That's all. Minus of 2.5. Yes, it's not there in the options. IM. Let me check. 43 question. Okay. I think this is 40. I think it is. This is 40, not this. Just let me correct it. I think this is 40. Okay. Opposite resistance by total resistance. This is 40. Therefore, this is 50. It should be minus 1. It should be minus 1. Yeah. It is 40. It is 40. Okay. So if it is 40, then answer is what? Minus 1. See, anyhow, it's irrespective of the values, it is very simple to answer. It is very simple to answer. 5 is the current. Current division it is. If you want this current, but direction is down, that's why I kept minus here. This current is coming like this. This current is distributed to this one like this, and this one like this. But that fellow given current direction in the opposite direction of the actual current flow direction. That's why I take it here minus. Apply current division. That's all. Apply current division. 44. Identify whether the given statements are true or false. the curl of any vector is scalar. No, curl of a vector is always a vector. Okay, never it is going to be scalar. While using paddle wheel as a curl meter, no rotation of the wheel means no curl. Yes, no rotation means no curl. Curl itself means rotation. Curl means rotation. Curl, see, curl means rotation. Curl of any vector is again a curl, again a vector. Never it is going to be scalar. Yeah, this is true. So 1 is false, 2 is true. 1 is false and 2 is true. Yeah, 2 is true. Let's go to the next question. How many coordinate axes are mutually at right angles to each other are set up in the Cartesian system? 3. Answer is 3. In Cartesian system, we have 3 axes x, y, z. That is direct question. 3 axes. Yes, x, y, and z. This is x, this is y, this is z. Though it is not visible to you as 90 degrees. Yes, this is 90. This is 90. This is also 90. Right? 3 it is. Next question. A step-up chopper is supplied through a source of 200 volts. Okay. Vs is equal to 200. Yes. Operated at a duty cycle of 50%. D is equal to 0.5. Then find the average output voltage of the chopper. Output voltage average is equal to Vs into 1 by 1 minus D. So 200 by 1 minus 0.5 will be 400 is the answer. Direct answer. No struggle at all. Directly you can tick for the answer. There is no struggle at all here, right? Next question. The divergence of the vector flux density A is the outflow of flux from a small dash surface per unit volume as the volume. It's a closed and shrinks to 0. Yeah, it's a closed volume which is shrinks towards 0. That is also choice A. Direct question. Okay, that is also direct point, right? Next question. What is the full form of RBSOA? Reverse bias safe operating area. Yes, reverse bias safe operating area. This is also direct question, right? Next question. Calculate the sensitivity of 0 to 1 milliamp ammeter. Sensitivity S is equal to 1 by that rating, I can say the full scale deflection divided by how much it is, 1 milliampere. So therefore it will be 1 kilo ohm per volt. Yeah, this is 1 kilo ohm per volt. Choice 4. This is also direct problem. Okay. Next question. Find the current I in the given circuit. He is asking about this current I. Okay. See, in many ways we can do. These two are in series, that is in parallel, that is in series. Then you are going to get this current. Then you can apply directly voltage. But instead of that, I'll take this one as a reference. I'll take this one as VA. Now, VA by 200 is this current, leaving current. This current is plus VA by 750 plus this current is VA by 500 is equal to 0. I'm assuming that all the currents are leaving at that point A, VA. Therefore, VA by 500 is this current. VA minus 400 by 200 is that current. VA minus, VA by directly 600 plus 150, 750 will be that current. That is equal to 0. If you solve this, you're going to get VA. Now, this current I is equal to VA by 750. VA by 750. You can do it. You're going to get the answer. Okay, directly if you do, you'll get the answer. It's not a big deal at all. Directly, just a solution. Just it is solution. Okay, let's go to the next question. Which of the following methods of speed control cannot be used for squirrel cage induction motor? Stator voltage and stator frequency control. Yes, it can be used. Stator voltage control. Yes, it can be used. Stator frequency control. Yes, it can be used. Slip power recovery control. It cannot be used. Why? Because that is the answer. This cannot be used. That is our answer. What he said, which of the following cannot be used? Which of the following cannot be used? Yes, slip power recovery control. Why? Because it is not possible to recover the slip power in squirrel cage induction motor. Why? Because it's a closed one. It's not in slip ring induction motor. Yes, there is a possibility to recover that power, but here it is not there, right? Next one. Which are the following types of instruments used only for AC measurement? Only for AC measurements means induction type. See, hot wire type, thermocouple type, PMMC type. See, this induction type is only used for AC measurement. Okay, because in DC frequency is 0. Induction principle works if and only if the given signal or the operating supply is AC. Right. Next question. Type C chopper is a combination of type A and type B. Type C is a combination of type A and type B. That is also direct question, right? What will be the effect on the force between two charged particles if the distance between them is halved and the charge on both the particles kept constant? Yeah, F is equal to K into Q1 Q2 by R square. F1 R1 I call. Now what he said, he he reduced the distance by half. R2 is equal to R1 by 2. Then F2 is equal to K into Q1 Q2 by R2 square. That R2 is nothing but R1 by 2 whole square. Now F2 is equal to, can be written as K into Q1 Q2 into 4 by R1 square. From this one, F2 is equal to 4 times of F1. F2 is equal to 4 times of F1. Force will be 4 times. Choice 2 it is 54, right? Next, a 20 millihenry coil is coupled with a coil of 5 millihenry. What would be the maximum possible value of the mutual inductance? So M is equal to, I wrote you the formula previously, K into under root of L1, L2. The maximum possible value of coefficient of coupling is 1. So M is equal to under root of L1, L2. We given it as how much? 20 millihenry into, yeah, 5 millihenry. That will give you 10 millihenry. Yes, choice 1 it is direct. See, you have to take this coefficient of coupling as 1. Why? Because he is asking for the maximum possible value. Okay, the maximum possible value of coefficient of coupling is 1. Next question, the transfer characteristics of IGBT is a plot of dash versus dash. It is a transfer characteristics is the this IC versus VGE. Yeah, collector current versus gate emitter voltage. Collector current versus gate emitter voltage. That is also direct question. Next question. In a magnetic circuit, for a coil having a single turn, yeah, N is equal to 1 is saying, N is equal to 1 is saying, then the flux linkage will be, what is the formula for flux linkage? Flux linkage psi is equal to N into phi. If N is equal to 1, psi is equal to phi. The option A is equal to total flux. Yeah, psi is equal to phi. If N is equal to 2, then twice the total flux. Half of the flux if N is equal to 1 by 2. 0 if N is equal to 0. That's all, right? Let's go to the next question. The electric flux passing through any closed surface is equal to the total charge enclosed by the surface. This statement is known as Gauss law. Directly, this fellow given Gauss law statement is asking, what is this? Yes, what is this, right? That is directly Gauss law. Next one. For which power device is the given symbol is used? Drain is given, gate is given, source is given. Yeah, this arrow is forward. This is P channel MOSFET. It is P channel MOSFET. If this arrow is this direction, then this will be N channel MOSFET. See, 59 it is 1. Yeah, a single phase transformer has 400 primary and 1000 secondary turns. Okay, if the primary is connected to 500 volt source, okay, see, N1 is equal to 400, N2 is equal to 1000, and V1 is equal to 500. Find the secondary voltage. Come on, yeah. V2 by V1 is equal to K, where K is equal to N2 by N1. Direct question. So V2 is equal to N2 by N1, 1000 by 500 into 400, right? So, sorry, 1000 divided by 500, 400, sorry, 1000 divided by 400 into 500. This is 400. N1 is 400. N1 is 400 into 500. Yeah, how much it will be? It will be 1250. 1250. Choice is 4. Choice 4 is correct answer, right? See, all are very simple questions. Ampere circuit law involves in finding about the current in a closed path. Yeah, did it? Total voltage, no. Total current enclosed by a closed path, yes. Total flux in a magnetic circuit, no. Total charge enclosed by a closed path surface, no. Ampere circuit law is related to current. Integral H dot dl is equal to I enclosed is the Ampere circuit law. This is closed integral. Okay. Next question. A uniform two-wire DC distributor is 200 meter long. He's saying that length of the distributor is equal to 200 meter long, and it is loaded with 2 ampere per meter. So current is equal to 2 ampere per meter. Okay, then total current I is equal to 2 ampere per meter into 200 meters. Then it will be 400 amperes. Na? The resistance of the single wire is 0.3 ohm per kilometer. Resistance is equal to 0.3 ohm per kilometer. Now, how many kilometers it is? He given it as 200 meters. Then R is equal to 0.3 into 200 into 10 to the power of minus 3. How much you are going to get? So this will be 60 into 10 to the power of minus 3 is the total resistance, right? 60 into 10 to the power of minus 3 is total resistance. Calculate the maximum voltage drop if the distributor is fed from one end. Voltage drop is equal to simply I into R if the distributor is fed from one end. Yes, voltage drop is equal to I into R. So voltage drop is equal, current is equal to 400. R is 60 into 10 to the power of minus 3. You are going to get it as 24 volts. 24 volts. 24 volts, but that is not the option. Then voltage drop in one wire is equal to 24 by 2, that is equal to 12 volts. Yes, the option is 12 volts. Direct question this is also. V is equal to I into R, but he given lengths and all, for how much length, how much current and all, right? Yeah. Let's go to the next question. In a single phase full converter, yeah, he's saying that single phase full converter for discontinuous load current and extinction angle beta greater than pi, each SCR conducts for dash if firing angle is alpha, for beta minus alpha. See, I'll write. This is the source voltage. Source voltage. He's saying that discontinuous conduction. Yeah. So he is giving firing angle alpha. Suppose then it is greater than beta. Beta is greater than pi. He said. Suppose if I'm taking this one as beta, now this is the entire conduction. Now this is alpha. From here to here it is conducting, therefore it is beta minus alpha, right? Next question. PMMC instrument can be used as DC voltmeter without series resistance in the range of 0 to 100 millivolt. That all of us know. That is a direct question. Okay. 64 is choice 3. Yeah, choice 3 or choice 2 it is. Choice 3. Fine. Yeah, next question. If the percentage reactance of the system up to the fault point is 20% and the base KVA is 10,000, base KVA is 10,000, then the short circuit KVA is equal to short circuit KVA is equal to base KVA by reactance by X. Base KVA is 10,000 divided by 20% means 20 divided by 100 it is. Therefore, it will be 50,000. Answer is 50,000. Choice is yes, 2. Choice is 2. 65. Yeah, 66. Super node is considered when there is a voltage source between two nodes. Voltage source. Yeah, we will encounter super node if and only if there is voltage source between two nodes. Right? Let's go to the next question. Per unit value of any quantity is actual quantity by base quantity. That's all. Actual quantity by base quantity. See, for these questions, you need not to have, I can say, like in deep explanation. All these are direct. Initial part of our learning is these things only. In power systems, we start with this one only. Okay. What is the purpose of per unit and what is per unit? Okay. Let's go to the next question. A DC 2-wire feeder supplies a constant load with a sending end voltage of 220. Calculate the saving of copper if the voltage is doubled with power transmitted remaining same. Okay, this is a question, good question to do. I'm solving it. He is saying that power is constant, P1 is equal to P2. Okay, but he said that voltage is doubled. He's saying that V2 is equal to 2 times of V1. Yes, now all of you tell me, if voltage is doubled, then obviously current is halved. Why current is halved? I'll tell you why current is halved. So V1 I1 is equal to V2 I2. Yeah, if V1 I1 is equal to V2 is 2 times of V1, then I2. So this got cancelled. From this one, I2 is equal to I1 by 2. I2 is equal to I1 by 2. If voltage doubles, current is halved, then only power is constant. He said that power transmitted is same. Now let me take a new page and solve. I'll solve there. Observe here. Now I2 is equal to I1 by 2. You know, cross section area of a conductor is directly proportional to the amount of current. If we want to send more current, we'll take more cross-section area conductor. If we want to send less current, we'll take less cross-section area conductor. That's all. Therefore, current is the area and the current both are directly proportional. Then A1 by A2 is equal to I1 by I2. Now A1 by A2 is equal to I1 by, this is I2 is what? I1 by 2. That implies A2 is equal to A1 by 2. Means the area of cross section required if the voltage doubled is half of the first case. Right? Now, what is area formula? Pi R2 square is equal to pi R1 square by 2. This pi gone. Therefore, R2 is equal to R1 by root 2. Means radius of the second conductor in which voltage got doubled is half of the, yes sir, I can say not half, root 1 by root 2 times of the first case radius. In the first case, if the radius of the area is A1 and the radius is R1, yes. In the second case, area is A2 and radius is R2. That R2 is R1 by root 2 times. R1 by root 2 times. Now, observe here, what is the volume of a cylinder? Pi R square into L, right? Volume. Now, he is talking about percentage saving of the copper. Then volume of the copper saved. Let me take V1 by V2 ratio. So volume 2 by volume 1 is equal to pi R2 square into L by pi R1 square into L. L gone, pi gone. So R2 by R1 whole square. See, this R2 and R1 are not. See, this R1 and R2 are radius. R2 and R1 are radius. What is R2? R1 by root 2 by R1 whole square. So this is equal to 1 by 2. This is equal to 0.5. Therefore, percentage saving in the copper is 50%. Look at the option. Look at the option. 50% it is. He given in terms of percentages. Answer is 50%. Choice 3 is the answer. Okay. Let's go to the next question. Which of the following is not valid voltage for primary distribution? 66 kV. See, 66 kV is a transmission level voltage, not distribution level voltage. Okay. Come. A power MOSFET is, yes, it is a unipolar voltage and majority carrier device. It's a unipolar voltage control and majority carrier device is MOSFET. Okay, a power MOSFET, in fact. Next one, in a transmission system, the cost of the conductor is proportional to the area of the conductor. Nothing to do with the color, nothing to do with the temperature, smoothness of the surface, nothing. Okay, cost is directly proportional to area of the conductor. Let's go to next question. You see, this is the third or fourth question on that mutual inductance topic. Inductance topic, self and mutual inductance. An inductor of 0.1 Henry is connected in series with an inductor of 0.4 Henry. If the coefficient of coupling is 0.6, then the mutual inductance between them is saying that inductor of 0.1 Henry and another inductor of 0.4 Henry, yeah, L1 is equal to 0.1 Henry, L2 is equal to 0.4 Henry. Coefficient of coupling, yeah, K is equal to, given it as 0.6, then M is equal to dash. Directly M is equal to, yeah, I don't know what happened to that fellow. Total 3 questions are given on the same topic. We are going to find one more question on the same topic. Okay, M is equal to K into under root of L1, L2. So M is equal to 0.6 into under root of L1 is 0.1 and L2 is 0.4. Solve it, you're going to get the answer. Just you solve this one, you can get the answer. Let's go to the next question. Find VM in the given circuit. He's asking about the VM. Apply voltage division. Previously, we got a question with current division, right? He asked us to find the IM. Okay, 5 is downside. Yes, 5 is downside. We saw. Now VM is equal to 8 into 25 by 25 plus 75. So VM is equal to 8 into 25 by 100. How much it is? 25 by 100. So 0.8. See, this is 0.08. 08 into 25. You solve it, you're going to get 0.08 into 25. You're going to get, right? Let's go to the next question. A single phase full bridge inverter has a DC voltage source of 230. Okay. Find the RMS value of the fundamental component of the output voltage. Fundamental, yes, is equal to 2 root 2 by pi into VDC. That is 2 root 2 by pi into VDC is 230. You'll get this one around 0.9 into 230. Then the answer is 207 volts. It is 207. The option is 2. See, I found no question is tough. Forget about whether it is tough or simple. All are direct questions. No question, no hidden formula also. You need not to think. Just see the question, take the answer. That's all, if you know the concepts. Next question is, a voltmeter is used for the measurement of a line voltage of 230 indicates 232. Find the static error. Find the static error. It is simple. Static error is equal to, yes, static error is equal to 232 minus 230 is equal to 2 volts. Choice 4 it is. Rightly? Choice 4. Next question. Identify whether the given statements with the reference to DC machine are true or false. Swinburne test cannot be performed on a DC series motor. Yes, because Swinburne's test is conducted on a machine under no load. DC series motor should not be operated under no load. It should not be operated under no load. Therefore, this is correct. Swinburne's test is a non-loading test. Yes, it is. Both are true. Both are true. True, true. Choice 3 it is. Choice 3. Next question. In a three-phase four-wire unbalanced system, the magnitude of the zero sequence current is a dash current in the neutral wire. Yeah, zero sequence current IA naught is equal to 1 by 3 times of IA plus IB plus IC. This IA plus IB plus IC is nothing but yes, neutral current, right? It is 1/3 of. It is 1/3 of. Next question. A potentiometer circuit, a cell of 1.5 volt EMF gives a balance at 30 centimeter length of the wire. If another cell of 2.5 volt EMF replaces the first cell, then what length of the wire will balance point occur? Yeah, he's saying that 1.5 volt is giving balance at 30 centimeter, then 2.5 volt, yes, 2.5 volt will give balance at x centimeters. So x into 1.5 is equal to 30 into 2.5. I think it is, yeah, 30 into 5 by 2 by 3 by 2. This 2 gone, 10 it is. It is 50 centimeters. In fact, 50 centimeters. Answer is 50. Choice 1 it is. Let's go to the next question. In a series RLC resonance circuit, at resonance, the current drawn by the circuit is at resonance. When resonance will occur? When XL is equal to XC. What is Z of series resonance? R plus J into XL minus XC. If these two are equal, this will be 0. Z is equal to R, that is yes, minimum. Impedance is minimum. Then current is equal to I is equal to, in fact, I is equal to V by Z. This is a minimum, then current will be maximum. Yeah, what he asked, current drawn by circuit is maximum. Choice 4 it is. Next question. Determine the regulation of transformer in which ohmic loss is 1%. Percentage ohmic loss is given of the output, and the percentage reactance drop is 5% of the voltage when the power factor is unity. What is the percentage voltage regulation formula? Percentage voltage regulation is equal to percentage RL cos phi r plus percentage XL sin phi r, where cos phi r is power factor, as cos phi r is equal to 1. Why? Because he given power factor as unity, then sin phi r is equal to 0, then percentage voltage regulation is equal to percentage RL, which is nothing but percentage ohmic loss, that is equal to 1%. Option is 180. Choice is 1. Very simple. Direct question. Direct question. Next question. Yeah, let's solve this question. A slide wire is used for the measurement of current in a circuit. The voltage across standard resistance of 1.0 ohm is balanced at 75 centimeters. So 1 ohm, 75 centimeters. Find the magnitude of the standard cell having an EMF of 2 volts is balanced at 50 centimeter. See, 1 ohm, 75, then 50 centimeter, how many ohms? R ohms I take, then R into 50 is equal to 75. So R is equal to 75, sorry, R is equal to, it is 75 by 50. R is equal to 75 by 50. Then current I is equal to, voltage is 2 volts. So because he said that 2 volt he applied, by 75 divided by 50, 100 divided by 75. 100 divided by 75. Is it, or any mistake we committed, or in the question any mistake? Let me see if there is any mistake in the given typed question. Question number is 81, right? Yeah, it is 81. Yeah, so 75. So okay, data is perfect. 75 centimeter, it is 1 ohm. Then 50, r into 75. Oh, here I committed a mistake. Here I committed a mistake. Just a minute. This is wrong. This is wrong. Let me erase. I'm erasing here. Okay. Yeah. Yeah. So otherwise I'll do in the next page. That will be better and fine for us. Yeah. I committed mistake in the calculation. Yeah. 1 ohm, 75 centimeter. Then 50 centimeter is r ohm, we don't know. Then 50 is equal to 75 into r is equal to 50 divided by 75. Current I is equal to V by 50 divided by 75. 75 into 2 divided by 50. This is 150 divided by 50. This is equal to 3 amperes. Direct answer is 3 amperes. Choice 4 it is. Direct question it is. Yeah. Here you see one more question on the concept of self and mutual inductance. Two inductors each are having self inductance of 1 Henry are connected in parallel with such a way that, so he's saying that L1 is equal to L2 is equal to 1 Henry. Both the flux act in the same direction if the mutual inductance is 0.5. M is equal to 0.5. Then find the equivalent inductance of the parallel combination. There is formula L equivalent is equal to L1. Sorry. L equivalent is equal to L1 plus L2 minus M square. Sorry, it is not L1 plus L2. L1 L2. It is L1 L2 minus M square by L1 plus L2 minus 2M. Now it is 1 into 1 is 1 minus M square 0.25 divided by 2 minus 2 into 0.5 will be 1. This will be, denominator is 1, numerator will be 0.75 Henry. Choice is 2.75 Henry. 82. Next question. A 746 kilowatt 3-phase 58 16 pole induction motor has a rotor impedance of 0.02 plus j 0.15 ohm at standstill. Full load torque is obtained at 360 rpm. Calculate the speed at which maximum torque occurs. So N is equal to Ns into 1 minus Sm, where Sm is the slip at which maximum torque occurs. So Sm formula is R2 by X2. R2 how much is given? 0.02 by X2 is 0.15. Ns is equal to 120 into F by number of poles are 16. So N is equal to 120 into 50 divided by 16 into 0.02 by 0.15. If you solve, you are going to get this one as 325 rpm. 325 rpm. 83 is yes, it is option 3. Next, which of the following is not an application of DC potentiometer? Measurement of resistance, no, it will do. Measurement of current, it will do. Measurement of power, it will do. Measurement of self-inductance. Self-inductance, that is done with AC, okay, not with DC potentiometer. Therefore, option 4. The next question is, yeah, this is 25 minus J25. It is 25 minus J25. If a circuit load impedance is 25 minus J25, find the power factor. See, Z load is equal to 25 minus J25. Then what is power factor? Direct question. Power factor is equal to R by mod Z. R is 25, mod Z is root of 25 square plus 25 square. That will be 1 by root 2, nothing but 0.707. That is option 3. See, we solved all the questions of electrical paper HPCL 2022 shift 1 paper. You can see all questions are damn easy. I found no question as difficult. The only thing is, you see, he concentrated on the areas which are not covered in GATE. That is very important. See, GATE, this preparation is completely different from GATE preparation. Okay, YourPedia is one of the largest platform for all competitive examinations. Okay, We are going to provide module in such a way that suitable for that particular exam. If you want to crack this HPCL exam, then join your hands with YourPedia. Okay, we will cover entire syllabus in the level of HPCL examination. Thank you.